Welcome, learners. Welcome to Black Slides Online Secondary School. If you are watching our video lessons on the YouTube channel, consider subscribing to the channel. The channel name is Black Slides Online Secondary School. It is important that you subscribe and also hit the notification bell. That will help you to receive notifications every time we upload a new video lesson. My name is Mr. Pochilola, your teacher on this platform. I represent Black Slides in Malawi. We meet now to revise the 2023 Msce Physics Paper 1. This is money paper. It's paper 1. So let me welcome you once again, whether you have just joined us or you joined us long time ago on this platform. You are welcome to the channel. Invite your friends wherever they are so that they too can learn from the channel and prepare fully for the Msce exams, which are just a few days away. My understanding is that your exams are starting on 29th June 2026. I hope you are making the best use of our revisions. In case you need any additional tuition, kindly send us a message. Send us a message to the numbers that we shared before, and we are going to guide you properly regarding the joining process, how you can join our main classrooms. Without wasting your precious time, let's get to the business of the day. We are revising the 2023 Msce paper. This is Physics Paper 1. Welcome, learners. Question number 1. What is the difference between absolute errors and relative errors? 1 mark. Right, so the examiners are asking you to differentiate between absolute errors and relative errors. So the response that was sought after here was for you to say that absolute error is the difference. It's the difference in magnitude between a measured value and the actual value. While relative error is the ratio of the absolute error to the actual value, expressed as a fraction. All right. So absolute error is just the difference. In a measurement, when you're doing a practical, you have the quantity that you're measuring, and there's also a value which is considered to be the actual value, or sometimes known as expected value. So when you take the difference between the two, the actual value or expected value minus the value that you measured, it will give you absolute error. Let's say, for example, you are measuring the boiling point of water at your school using a thermometer. Suppose you find that the boiling point of water at your school is, say, 98 degrees Celsius. But you know that the actual boiling point of water is 100 degrees Celsius if it's pure water. So the difference between the actual value, which is 100 degrees Celsius, and the value that we found, which is 98 degrees Celsius, the difference between the two, which is 2 degrees Celsius, is absolute error. While the relative error is just the ratio, the absolute error which you found there divided by the expected value. So in case of this example I gave, the absolute error is 2 degrees Celsius. The expected value is 100 degrees Celsius, so 2 over 100 is going to give you a relative error. The error in your measurement compared to relative. Relative means compared to the actual value. Let me urge you to go back to your notes on the errors. This must be measurements, I think, in Form 3 physics. So go back and look at the different kinds of errors, experimental errors, such as the random errors, systematic errors, zero errors, the different kinds of errors. Go back and revisit that so that you are sure of the real definitions of the different kinds of errors in an experiment, experimental errors. At least in 2023, we had a question that required the candidates to differentiate between absolute errors and relative errors. Next time, they can ask you for differences between a different pair of errors, let's say systematic errors and random errors. Welcome, learners. How can a long-sighted person or problem be corrected? A long-sighted person is able to see objects that are far away and fails to see objects that are nearby. So how can you correct this? This is too much. So a long-sighted problem or long-sightedness can be corrected by simply placing a convex, sometimes known as converging lens, which can cause the rays of light to meet at the retina and form a focused image. To 2 marks, the problem can be corrected by placing a convex or converging lens, that's 1 mark, which can cause the rays of light to meet at the retina and form a focused image. Welcome, learners. How can repeating an experiment minimize errors in an investigation? Repeating And the averaging an experiment is a way of correcting random errors. Remember, random errors are errors that fluctuate in a measurement, especially when you take several measurements of the same quantity. You find that the error keeps changing. So such an error can be corrected by simply repeating the experiment a number of times and averaging, taking the average, the random errors basically. The examiners here wanted to check if you know that repeating an experiment deals with random errors, not systematic errors or instrumental errors. All right, so how does repeating an experiment minimize errors in an investigation? So, repeating an experiment minimizes random errors. Random errors are the errors that keep changing, that keep fluctuating in a measurement. So it minimizes random errors which arise from the inconsistency in the repeated measurements of the quantity. So each time we measure a quantity, we find that it's different. One quantity is different from the other, yet you are using the same instrument. Find that the next quantity is different from the other one, yet you are measuring the same instrument. So you can correct those by simply repeating the experiment a number of times and then take the average. It's going to fix the error. 2 marks minimizes random errors. 1 mark, which arise from the inconsistency in the repeated measurements of the quantity. Another mark. That's what makes 2 marks there. Welcome, learners. Figure 1, which is this one here, is a diagram showing a thermometer that reads 31 degrees Celsius. Use it to answer the questions that follow. So we have this as a diagram. The reading is 31 here. What quantity does the instrument measure? This instrument is used to measure a quantity called temperature. So by just saying temperature here, you get 1 mark. If a student reads 30 degrees Celsius, what type of experimental error is made? The actual reading is 31, but let's suppose that a student, for some reason, reads the thermometer as 30 degrees Celsius. What type of experimental error is made? This error could be due to poor location or positioning of the eye with respect to the scale. So probably this could be parallax error, which is also called observational error. Parallax error is when you mislead a quantity. You take a reading wrongly because of the poor positioning of the eye with respect to the scale of the instrument. Parallax. Let's say maybe the eye was positioned somewhere there, so the student is looking at this as 31. All right, that's parallax. It is observational error. Welcome, learners. My name is Mr. Pochilola once again. In case there are questions, leave a comment. Leave a comment in the comment section below, and we are going to come back with a reply to the comment. Question number 2. Give any 2 ways of preventing dangers of radioactive substances. Remember that radioactive substances are dangerous in many ways. They can cause cancer if not handled properly. They can cause mutations, genetic mutations, and if ingested, they can lead to death. So there are ways to prevent those dangers. That's what the examiner is asking us to give. Any two marks. That means each is 1 mark. There are quite a number of them. One of them is to handle radioactive substances with forceps and not with bare hands. By saying this, you have 1 mark. You should cover any cut on the skin before handling radioactive substances to avoid ingestion, rather to avoid entry of substances into your body through the cut. Handle radioactive substances with forceps. These are equipments you can use to hold or to handle radioactive substances. Don't use bare hands to handle them. Cover any cut on your skin before handling radioactive substances. This ensures that you don't permit entry of the substances into your body through the cut. Do not drink, eat, or smoke when handling radioactive substances. If you work in a place where there are radioactive substances, such as in the mine, for example, don't take chances. Don't drink anything. Don't eat or smoke anything. In so doing, you may end up swallowing or ingesting the radioactive substance that would cause catastrophic danger in your body. Welcome, learners. Do not point radioactive substances towards the human body. For any reason, don't point radioactive substances towards another person. Otherwise, the substance can enter the other person's body and cause injury or problems. So any 2 of these will give you 2 marks. So make sure you know all of them so that in an exam you are not stranded, you don't run out of ideas. How does beta radiation occur? Remember that there are 3 types of radiations, namely alpha, gamma, and beta radiations. So in a 2 marks question, the examiner is asking us, how does beta radiation occur? Beta is negatively charged. It resembles an electron with no mass, and it has a negative charge. It is a negative charge carrier. So the question is, how does it occur? How does beta radiation emission occur? It is the emission that occurs, by the way. Not beta radiation itself. How does beta radiation emission occur? In other words, how is beta emitted from unstable nucleus? So for Later to be released, a neutron changes into a proton, followed by the release of negatively charged particle called beta, 1 Mach, 2 Machs. A neutron in the nucleus, that is, which is an unstable nucleus, a neutron changes into a proton. The formation of the proton from the neutron will be followed by a release of negatively charged particle, which is called beta, 2 Machs. Welcome, learners. Why does sugar spread faster when dropped in warm water than in cold water? This is about kinetic theory of matter. All right, so you drop sugar into warm water, you notice that it spreads faster than when you drop the same sugar in cold water. The question is why? Three marks. In your answer, make sure you present 3 points. Remember that the number of marks indicates how many points you need to raise in your answer. Welcome, learners. So in warm water, sugar particles gain kinetic energy, 1 Mach, causing them to move faster in different directions in the solution, another Mach. Hence, it spreads faster than in cold water, another Mach, 3 Machs. So you gain Machs. In warm water, sugar particles gain kinetic energy, that's 1. Moving faster, the particles move faster due to the gain in kinetic energy. The particles move faster in different directions in the solution, hence spreads faster than in cold water. 3 marks. Take note. Avoid giving incomplete answers in an exam. You end up losing marks. So make sure you are as complete as possible. Welcome, learners. Number 3, convert 45 microamperes into amperes. Micro, remember micro is 10 to the power minus 6 micro. So 45 microamperes is just the same as 45 times 10 to the power minus 6. So this 10 to the power minus 6 is just the same as a micro, this one over here. So simply take 45 multiplied by, this is called a prefix, it's called a micro. So 45 multiplied by 10 to the power minus 6 amperes. And remember to write this in standard notation. So you have to shift once, the decimal of once between 4 and 5. You have this one here. By shifting I think something is not all right here. All right, so this is the same as 4.5 multiplied by 10 to the power 1 multiplied by 10 to the power minus 6, which is micro. Amperes. All right, so when you add the powers of 10, you have 4.5 times 10 to the power 1, add minus 6. Welcome learners. So this will give us 4.5 times 10 to the power minus 5. This looks better now. Not this one here. What's wrong here is the power. Welcome learners. So revise your physics from 3 prefixes. This is from a topic called prefixes. It's measurements and the subtopic prefixes. So you have nano, picos, kilos, mils, des, and so on. Practice a lot on conversion. So this is going to be 4.5 times 10 to the power minus 5. I think there was a mess up here. Messed up a big deal. Give any 2 reasons why the amplitude of an oscillating pendulum decreases with time. Two reasons why the amplitude of an oscillating pendulum decreases with time include air resistance. So air resistance slows down the oscillating pendulum, thereby reducing the amplitude. Air resistance, but also friction between the string and the clamp. The clamp which holds the string slows down the oscillating pendulum. 2 reasons for 2 marks. For A, you find that the speed here corresponds to 10 meters per second. So bring that in. Distance covered is equal to velocity times time. This is the same as displacement. It's all right. Okay, so distance covered is velocity times time, or this speed times time. So substituting, the distance covered is 65, the speed is 10. Solving for time, t, you divide 65 by 10. So the time taken is 6.5 seconds. 3 marks for correct substitution, formula, correct substitution, and answer. We'll give you 3 marks. Question number 5, A1. Define electrical resistance. We define electrical resistance as simply the opposition to the flow of an electric current in a circuit. As current is flowing in a circuit, it experiences an opposition due to the particles in the conductor. That opposition is called the electrical resistance. Calculate the resistance of a bulb in which a voltage of 9 volts causes a current of 2.5 amperes to flow in it. So here you need to apply what is called Ohm's law. Ohm's law, from Ohm's law, resistance is equal to voltage divided by current. So voltage is given to us as 9 volts and current is 2.5 amperes. So 9 volts divided by 2.5 is 3.6 ohms. Don't forget the units of resistance, which is the ohm. So 3 marks. 1 mark for the formula, and then another mark for substituting correctly, and if lastly the resistance. Welcome, learners. If you have not already subscribed to this channel, consider subscribing so that you get updates. We are going to do a lot of revising this month and part of next month, especially towards the practical papers. So stay with us. Welcome, learners. Calculate the frequency of a red light of wavelength 5.5 times 10 to the power minus 7 meters, taking 3.0 times 10 to the power 8 meters per second as the speed of the electromagnetic wave. Using the wave equation, frequency is equal to speed over wavelength. This is obtained from the fact that speed is equal to frequency times wavelength, but now here we've made frequency the subject of the formula. So dividing speed by wavelength, speed is 3 times 10 to the power 8 meters per second, and wavelength is 5.5 times 10 to the power minus 7. Dividing the two shall give us 5.5 times 10 to the power 14 hertz. Don't forget the units of frequencies, the hertz. After H and small z. Give any two properties of magnetic field lines. Remember that magnetic field lines are the field lines, imaginary lines, between the poles of a magnet. All right, so there are some properties that apply to magnetic field lines. One of them is that the magnetic field lines seem to originate from the North Pole to the South Pole. That's one, and not the other way around. The field lines are more concentrated at the poles of the magnet. You find that you have a lot of lines drawn there at the South Pole and North Pole. The magnetic field lines seem to come together at the poles, but not right at the ends. And lastly, magnetic field lines do not cross each other. So these are the properties of magnetic field lines. Welcome, learners. My name is Mr. Paul Chilola, your teacher on this platform. Question number 6, state any two examples of electromagnetic waves. We have 7 of them, so you are asked to name just 2. So you can name radio waves, microwaves, infrared, visible light, UV radiation, X-rays, or gamma rays. The question is asking just for 2. There's no way you can go wrong on this. Draw a circuit diagram in which a diode, a bulb, and a cell are connected in series such that the diode is forward biased. When the diode is connected in a forward biased mode, it means that it's allowing current to flow through that. So for it to be forward biased, it must be connected in a way that the cathode of the diode, which is this end, mostly negative, is connected to the negative of the cell. While the anode, which is this end here of the diode, must be connected to the positive terminal of the cell. So this is called forward bias. So the lamp is going to light. But if you reverse, let's say the cathode end comes here, the anode goes that side, the bulb is gonna go off. Or if you simply switch the terminals of the cell, the bulb is also going to go off. So this is the correct connection. The examiners are assuming you know the symbol for diode. Don't draw funny symbols, right? You lose marks. So here you have a mark for correct symbolism, correct symbol for diode, correct symbol for cell, and the rest of the circuit, including the lamp. Well, of course, this is not the symbol for a lamp. Just put this one here to indicate that it's giving light because the diode is correctly connected in a forward bias mode. This is not the symbol for lamp. Okay, so welcome learners. So correct symbols and the rest of the circuit. We have 1 mark, I mean 3 marks. How does a light-dependent resistor work? In short code LDR, 2 marks. All right. The points that the examiners are looking for in this description of the working of an independent light-dependent resistor, they want you to say that during the day or in daylight, light shines on the LDR, on the light-dependent resistor. 1 mark. Its resistance decreases and more current flows in the base of the resistor, hence conducts electricity. That's 2 marks. State the use of Archimedes' principle. All right, I think here something is not all right. We are, instead of stating the use of Archimedes' principle, we have stated what the principle states. But here you can mention something like sinking and floating of ships as an example, as one use. Sinking and floating of the ship. Yeah, not to state what the principle says. This is obviously wrong because we are not asked to state the law, the principle, but to say one use of it. So it's a sinking and floating of the ship is the answer to this one. Thank you. Calculate the weight of the water displaced when a 20 kg mass object immersed in water weighs 13 newtons. Okay, so here we shall need to apply the law. Archimedes' principle states that when a body is wholly or partially immersed in a fluid, that body is going to experience an upthrust, which is equal to the weight of the fluid displaced. So yes. So here we have an object whose mass is 20 kgs being immersed in water. When immersed in water, the weight of the object is 13 newtons. So calculate the weight of the displaced water. So first of all, we must find upthrust here. Remember, upthrust is the weight of the object in air minus the weight of the object in the fluid. So we must change this to weight in air by multiplying by 10, so to give us 200 newtons. It looks so big compared to the weight in the water. At least the difference could have been a bit smaller. But here what's going to happen is you have 20 kgs changed to weight. It's going to give you 200 newtons. So upthrust is going to be the weight in air, which is 20 multiplied by 10. minus the weight in the water, which is 187. Therefore, this is upthrust, and according to Archimedes' principle, upthrust is equal to weight of displaced water. So in this case, the weight of the displaced water is going to be 187 newtons. This is too big a force. So the marks are distributed in a way that you are able to apply this formula, substitute correctly to find this, and then to deduce the magnitude of the weight of displaced water. Welcome, learners. A man moved a trolley through a distance of 10 meters on a horizontal ground. If he applied a force of 75 newtons at an angle of 30 degrees to the horizontal, calculate the work done in moving the trolley horizontally. Okay, so the diagram, the situation is like this. We have a body here, trolley, let's say, being moved by applying a force at this angle to the horizontal, covering a distance of 10 meters. What is the work done? So work done at an angle is given by the formula force times cosine of the angle multiplied by distance. This must have been cos of theta, but anyway, we substituted the angle right away. So F cos theta times D. I've seen some candidates forgetting to multiply by the distance. All right, so our force is 75 newtons multiplied by the cosine of 30 degrees, which is 0.866, multiplied by the distance, which gives us 650 joules of work done. So don't forget, it's not just a matter of multiplying the force by distance. No, you need to use the cosine. You need to use the cosine of the angle 30 degrees and multiply out to get 650. Take note that we have rounded this number to the nearest two significant figures, because all other numbers in the diagram except in the question except this 10 meters and the 30 are, this is two significant figures as well. So let's leave our answer like that. Number 8, give any two examples of scalar quantities. There are many of them. All right, mass, time, speed, distance, energy, pressure, and many others, just two. Remember that scalar quantities have no direction, they only have magnitude. So mass, time, speed, distance, energy, pressure. Don't write all of them, just give any two, but I would urge you to know all of them so that you can give any two. You should also take advantage of this to revise on examples of vector quantities, because the opposite of scalar quantities is vector quantities. Welcome, learners. Two forces, 40 newtons and 50 newtons, are acting at an angle of 60 degrees to each other. Using a scale of 1 centimeter to represent 10 newtons, draw a diagram to show the resultant force. 3 marks. So we have the vectors. Let's say this vector here of magnitude 40 newtons. And another vector of magnitude 50 newtons acting here at an angle of 60 degrees. This angle here is 60 degrees. So we are given a scale, using a scale of 1 centimeter to represent 10. The 40 newton force, so it means will be represented by 4 centimeters line, while the 50 Newton force will be represented by 5 centimeters. All right, so applying the parallelogram rule of vector addition, we complete a parallelogram. Something like this. You draw a line that is parallel to this end. So this is equal and parallel to this 4 centimeter line. And another one parallel to the 5 centimeters line. So you draw this angle using a protractor properly. So the resultant vector will simply be the diagonal of this parallelogram, shown like that. Welcome, learners. Then find the size of the resultant. In order to do that, just take a ruler and measure this length. Let's say you find 6 centimeters. This is our resultant. So 1 centimeter is to 10 newtons. As given there, that means 6 centimeters will be 6 times 10, which is 60 newtons. Welcome, learners. That's how this should have been done. Question number 10. Figure shows an oscillating mass spring system. You have a mass attached to spring. Identify the amplitude of the oscillating system. Amplitude is the maximum displacement from the equilibrium position. So in this case, the amplitude could be PQ or QR. So the maximum displacement about the resting position is this much, is 5 centimeters, or this one here. So either PQ or, QP or QR, because they're the same. Identify the equilibrium position of the system. So the equilibrium position is a Q. That's where there's zero displacement. Welcome, learners. If the mass moves from P to R in 5 seconds, calculate the frequency of the system. Frequency, remember, is number of complete oscillations divided by time. So in that diagram, there is only one oscillation, which will take 10 seconds. From P to R, it takes 5 seconds. That means from R back to P, it will also take 5 seconds. That's why we're dividing by 10 here. So frequency will be 1 over 10, which is 0.1 hertz. State any two applications of circular motion. Remember, circular motion is motion of a body along a circular path. So there are quite a number of applications. A car, for example, negotiating a circular path on a level ground, horizontal ground, that's the application of circular motion. Banked tracks or banked roads, these are roads that are raised a little bit on one side in order to compensate for the centripetal force, or to provide the car as it's negotiating a corner or a bend to help it have enough centripetal force to keep it in a circular track. Leaning inwards of a cyclist when negotiating a bend would bend a little bit in order to negotiate a bend without problems. An aircraft banking, aircraft's bodies are tilted in the air whenever a bend is being negotiated. Another application is the conical pendulum and the a centrifuge. You are just stating after, you're not explaining, but I would urge you to go and explain how these are applied, how circular motion is applied in these circumstances. Welcome to section B, in which you have essay questions. Figure below is a diagram illustrating stages of a ball bearing falling in a jar containing oil. So this is oil, and then these are different positions of the ball bearing from A through B to C. Describe the motion of the ball bearing from A to C, from A to C. So let's start from there. When the ball is dropped, when the ball has just been released into the oil at A, there are forces acting on it. Three forces act on it, which are friction force, the force due to the viscosity of the liquid. There's also upthrust, which is the force pushing this up, and its own weight. So friction force and the upthrust are opposing forces pushing, acting on the ball upwards, and then there's the weight of the ball downwards. So these forces need to be identified in your description. So initially, the weight is greater than friction force, and the upthrust weight is downwards, and while upthrust and the friction force are upwards. So the weight of the body is greater than the sum of these two upward forces. That's why here it's slow. The closeness of these images shows that the body is moving slowly. It's slowed down by the initial weight is greater than frictional force and the upthrust. Okay, so the downward force is greater than the sum of the two upward forces, in this case the frictional force and the upthrust. Hence, the ball accelerates downwards. So the ball is accelerating downwards. Here it actually shows that the ball is accelerating downwards. Why? Because its weight is greater than the opposing forces, namely the upthrust and the frictional force. So as it accelerates downwards, frictional force starts to increase while weight starts to decrease. So frictional force between the liquid and the ball starts to increase while weight starts to decrease. All right, so the ball reaches a terminal velocity at B. The ball is going to reach a terminal velocity, which is the maximum velocity, when the weight of the body equals to the frictional force and upthrust. So the sum of the upward forces equals to the downward force. So as a result of that, the body accelerates at this terminal velocity until it reaches point C. These are the points that you should have included in your description for 6 marks. Welcome, learners. Explain the way an optical projector works, 4 marks. I'm not sure whether this is asking for slide projector or what kind of projector, but I'm sure it's referring to slide projector, which is also an optical projector. So in an optical projector, the light from the source, which is the lamp, illuminates the object slide by passing through the condenser lenses, which concentrates light rays onto the slide. This is 2 marks up to here. So by saying the light from the source illuminates the object slide by passing through the condenser lenses, 1, which concentrates light rays onto the slide, 2 marks. The projection lens converges the light rays onto the screen, 1 mark, where an image of the object slide is formed. So that's how the projector works for 4 marks. Question number 5. Explain how the floating in ships occurs. Remember that one of the applications of Archimedes' principle is sinking and floating of the ship. So in 4 points, we are asked to explain how the floating in ships occurs. So for a ship to float or sink, of course the question is just asking us for floating in ships. So we have to be a bit careful. A submarine has what are called ballast tanks, which are located internally in the ship, inside the ship, meaning you can't see them outside there. So the ballast tanks expel water by compressing water. They expel water by compressing the water. This creates upthrust and the submarine towards the submarine ship. Hence, the density of the submarine becomes less than the density of the water. Then the submarine floats up to here. That's where the answer ends. Whatever we say down here will not attempt to answer the question. So submarine has ballast tanks which are located in 1 mark. The ballast tanks expel water by compressing water, 2 marks. This creates upthrust towards the submarine ship. Hence, the density of the submarine, up to here 1 mark, of the submarine becomes less than the density of water. Then the submarine floats on the water. That's 1 mark. A total of 4 marks. Just go through this, make sure that you can present them in a way that does not change the meaning. All right, we are only looking at a situation where the ship is floating, so you can ignore what we said down here. Welcome, learners. 6 marks. Question number 13. How can the stacked glass tumblers be separated? This is an application of thermoexpansion of matter. All right, you can use thermoexpansion, our knowledge of thermoexpansion, to separate tumblers that are stacked. So in order to do that, the outside tumbler is for a short time momentarily placed in hot water, making sure that the water should not get into the inner tumbler. So on the other hand, the cold water can be put in the inner. This is just an alternative. Cold water can be put in the inner tumbler at the same time. All right. So the outer tumbler expands, hence the tumblers loosen. And then the tumbler, the inner tumbler, can thus be pulled out. So 2 marks here, 2 marks there, and 1 mark. Can have 2 marks here, 1 mark here, 2 marks here to make a total of 5. Figure below is a diagram of a transformer. How does the transformer work? For us to explain how this works, we need to identify what type of transformer this is. This is probably a step-down transformer. How do we know that? It has more coils in primary coil, more turns in the primary coil, and fewer in the secondary. That means this is a step-down transformer. All right. If it was step-up transformer, it would have fewer turns here than in the secondary. The explanation could be different. Right? So when the alternating current, remember that the transformer works with the alternating current in order to produce a changing magnetic flux in the core. We need the alternating current. So when an alternating current passes through the primary coil, here, it produces an alternating magnetic flux in the core. It produces a magnetic field or core or flux in the core. The core is this iron. All right. So the alternating magnetic field cuts and recuts the secondary coil, cuts and recuts the secondary coil, and induces an EMF, which is an electromotive force or a voltage in it. Since there are more turns in the primary than in the secondary coil, the induced EMF is probably going to be less than that of the primary coil. This is called describing how the transformer, especially the step-down transformer, works. Let me ask you to also explore how a step-up transformer works. My name is Mr. Pochilola. We've revised the full 2023 paper. You forgive me, in some cases I had to go a bit faster because we have to limit the paper to within 1 hour. So this has been 1 hour and 2 minutes. Welcome, learners. Bye bye for now.